feel like you have to wait for me to respond to be able to post. If you can answer your peers' questions, all the better. This week, our topic is implicit differentiation. In calculus, we will want to solve for y as a function of x so that we can calculate the derivative. However, there are going to be types of equations that do not allow us to do this. When we stumble across these types of equations, we use implicit differentiation to find dy dx, then solve our equation for this quantity. An example of an equation where we would need to use this method is looking at the equation for the unit circle, x squared plus y squared equals 1. That y squared is not going to allow us to completely isolate variable. If we solve for y, we'd get plus or minus the square root of 1 minus x squared. That plus or minus is going to prohibit us from being able to take a derivative, which is where implicit differentiation comes in to save the day. And that is the process we will be looking at today. It's very important to remember the rules for notation that I mentioned a few weeks ago, where dy dx is a quantity. We can treat it just like a variable. And then d dx is what we would call an operation. D dx is just like adding, subtracting, multiplying, dividing, squaring, taking the square root. It's just another operation. So remember, dy dx is a quantity and d dx is an operation. Please remember to keep those two separate. Very important. All right, so we have the steps to implicit differentiation, and these come right from your textbook. Your textbook lists them as 2 steps, but I understand them better as 3 separate steps. The first step is to differentiate both sides of the equation with respect to x, or whatever your independent variable may be. When we're using this process next week for related rates, this will usually be t for time. And in doing this, you're going to treat y as a differentiable function of x, and that's a lot easier than it sounds, I promise. So once you've taken the derivative and differentiated both sides, you're going to collect terms with dy dx on one side of the equation and then solve for dy dx. Let's look at this example right here. Find dy dx if y squared equals x squared plus sine xy. We're going to start by taking the derivative, d dx, of both sides. If we take the derivative of the left side, we'll get 2y, treating it as a differentiable function of x. And then we put dy dx, reminding us that we are working with that y variable. On the other side, we have to remember to distribute this operation. The derivative of x squared is 2x. And then we have to take the derivative of sine xy, which would be cosine xy. Oh, but it's the chain rule, so we have to take the derivative of the inside as well. So cosine xy times the derivative of xy. Now, don't be fooled by this. Please make sure to remember in this chain rule that you use your product rule. This would not just be y as an answer. We do need to go ahead and use our chain rule and our product rule here. Our product rule would tell us that the derivative of xy would be 1 times y plus x times dy dx. All right, so now we've differentiated all parts of this equation, leaving us with 2y dy dx equals 2x plus cosine y times y plus x dy dx. It sounds like a mouthful, but the hard part's done. We've done the differentiation. Now we need to start algebraically manipulating this so we can collect all the terms with dy dx on one side of the equation. do so, we're going to have to distribute this cosine xy. That leaves us with y cosine xy plus cosine xy times x dy dx. All right, now that we've distributed, we're ready to go ahead and move to the left side our term with the dy dx. So we're going to move this whole mess, our cosine xy, x dy dx, all of that's moving to the left side of the equation. And we do that by subtraction. Subtracted from one side, now we're subtracting from the other side. Now on this left side, I'm going to factor out my dy dx. Which will make the process of solving for it much easier. So that leaves me with dy dx times 2y minus x cosine xy. And this leaves us open for our last step of dividing both sides by 2y minus x cosine xy. This will make sure that we have isolated our dy dx. And that will leave us with 2x plus y cosine xy over 2y minus x cosine xy. Now we have successfully used implicit differentiation to take the derivative of our function. Well, I hope that this video was helpful and clearly laid out the steps to implicit differentiation. Best of luck in your homework this week. Please, you will see that there's some videos about related rates. I ask that you do not begin the videos or any content related to related rates before finishing your implicit differentiation homework. All of your implicit differentiation homework, all the videos, all the discussions should all be completed before you start any of the related rate content. You need to be pros at implicit differentiation before you're going to be able to tackle the related rates. You're going to find that we're going to have 2 weeks worth of videos on related rates, and that these problems are very long. You can expect that next week's homework is going to be a little on the long side because these problems do take a lot of time to work. This week, I want you guys to focus on becoming pros at implicit differentiation. Have a great week.